Hello, I'm Cassio Zen on Twitter and everywhere else. I'm a software engineer at Microsoft, and I believe that in the near future, no reasonably complex JavaScript applications will be done without static type checking. I'm talking, of course, about tools such as TypeScript and FlowType. And the most popular reason to use these tools is because they catch bugs. And while that is true, I'm more excited about what comes next, as more and more code bases start using TypeScript and FlowType, as we've been seeing with the increasing popularity of these tools. These other benefits will become more evident, and I'm going to talk a little bit about those as well. At the end, I'm going to show you what it takes to learn these tools so you can decide for yourself whether they are worth your time or not. Cool. So let's talk about the first example, catching errors. JavaScript, of course, has types. It has, every time you create a variable or you pass an argument to a function, that value, it's either a Boolean or a number or a string, undefined, null, or symbol and big int, which are new to JavaScript, but it has to be one of those. But JavaScript is also loosely typed. And while that is a source of great flexibility, it can also be a source of bugs. Let me show you what I mean. I have this code here and I say that price equals 100 and I'm calling price.toFixed. Now, toFixed is a function that only exists on numbers. It doesn't exist on strings, it doesn't exist on Booleans. But because of JavaScript's loosely typed nature, it allows me to come here and say price equals cheap. And now I have a bug in this application. And while the bug here is quite obvious, you can imagine that if this file were much bigger and these lines are spread across, or maybe the values come from as arguments from a separate file, you can imagine that I might lose track of these. And also because in JavaScript you can only detect errors as you run your application, either in Node or in the browser. If this isn't something that happens at all times, if this is not on the main path, it's something that only happens sometimes, I might not catch it and it will explode in the face of my user. In my career as a software engineer, I've never seen a JavaScript project that didn't have at least a couple of these. So how does FlowType and TypeScript help with that? So I'll step back and how it was originally, now using TypeScript. It would be identical if I were to use FlowType here, but I'm going to use TypeScript in these examples here. Now, by inference, TypeScript knows that this variable here is numeric, and it will enforce that this variable remains a number throughout my application. So if I try to come here and say price equals cheap, it will immediately complain and say that I cannot assign cheap to a number. So problem fixed, I cannot ship this code. Cool. Can I make this variable accept a string if some crazy case I wanted that? Yes, you can. By inference, TypeScript will, of course, infer whatever is the type that you pass here. But if you want, you can add these special annotations, this column here, and specify the type yourself. So I can say that this variable here can hold a number or a string. And now line 2 here is valid because now I'm assigning to a string and the strings are allowed. But notice that this code here, it still contains a bug. So one way or another, TypeScript is going to say, well, now the problem's here because strings doesn't have toFixed. So we'll force you to fix that either by, I don't know, checking if the type of price is a string or something like that. So this catches a whole category of bugs related to types. Another category of bugs that TypeScript and FlowType help with are nulls and undefineds. You know how it goes, right? You have this function, it accepts a string, but somehow it gets called with undefined, and you have these errors that says like cannot find property whatever of null or of undefined. Well, in TypeScript, if I say that this is a string, I cannot call this function passing undefined, or not passing anything which would be the same thing as passing undefined. It immediately says that, well, it has to be a string. Now, can I make it so that it accepts undefined? Yes, of course. Just like in my previous example, I can say that it accepts string or undefined. In TypeScript, there is even a special notation for that. You can just use a question mark here. But notice that I still have a bug because to locale uppercase only is only available on strings. So now TypeScript one way or another says that, well, there's an error here. So I can, for example, check. Let's do it here. So if type of user equals a string, then I can return that. So now it's valid. Oh, sorry for the error here. Cool. So how many bugs does these tools catch? Well, it's really hard to quantify exactly the number of bugs. But there has been some studies, and there is one study that says that it catches around, this study was made specifically comparing open source JavaScript files to JavaScript projects to what would be possible using TypeScript or flow type, and they reached the conclusion that around 10 to 15% of the bugs could have been caught by these tools. And I don't know about you, but if you could make a change to the way we do development that would reduce the number of bugs being checked in by 10% or more overnight, that's a no-brainer. Unless it doubles the development time or something, we would do it. And that's not me saying, that's some engineering manager, other engineering manager at Microsoft that participated in this research. So cool, it catches a lot of bugs, that's very useful. But as I mentioned before, catching bugs, finding errors before it reaches your user, while very powerful, is one of the benefits that these tools provide. But I'm super excited to talk about different ones. So another thing that they bring is smarter tooling. Creating tooling, text editors, IDEs, you name it, for dynamic languages has been notoriously hard since forever. I'm talking about things like auto-completion and things like that. But TypeScript and FlowType, they provide just the necessary amount of hint that is needed to create smarter tools. So let me show an actual example. So I have here this other application. And it's a Pokemon application. I have like Pokemons and I display a list of Pokemons. And if you know what a Pokemon is, well, you know what a Pokemon is. So it's a very natural way of expressing grouped data together in JavaScript is by using objects, right? So here I have, for example, where is it? Here. Throughout my application, I pass objects like these representing my Pokemons. It's an object that contains a name, a level, and a type. And these are used throughout my whole application. Now, the problem is, what happens if I need to refactor? For example, what happens if type is not a string anymore because Pokemons can have more than one type? Well, if you're using tools like TypeScript and FlowType, they allow you to, in this case here, make your own type alias, make your own shape of an object that other objects has to conform to. So here I'm creating this type called Pokemon, which is an object containing a name string, a level which is a number, and a type which is a string. And throughout my application, my functions, my variables, they declare themselves as expecting a Pokemon. So I cannot pass anything that looks different than this. And this also helps me a lot, we're talking about tooling, when I need to make changes. So as I mentioned, these can be an array of strings. So I'm going to make this change here. I'm going to say that this is now an array of strings. And look at my file tree here as I save this application, as I save this file. As you can see, because I'm using TypeScript and TypeScript provide hints to my application, to my Visual Studio Code here, I can immediately see all the files that are impacted by this change and that I need to change. And notice that the files that are highlighted here are not all the ones that uses the Pokemon type, are the ones that uses Pokemon type and uses this type here in a way. So for example, this file here, it's testing to see whether type is a string electric, but now type is not a string anymore. So it only impacts the files that really need to change, and it also gives me, as you can see here, some explanation. So this helps a lot with refactoring with confidence. In fact, when TypeScript was created, one of the reasons for creating TypeScript was that the creators of the language, they felt that many big and complex JavaScript applications, they became kind of append only through time. People were so scared of making changes and refactors that they would only add without refactoring. So these tools, such as TypeScript and FlowType, they allow for a much better idea and a much better help when you try to do refactors like these. Let me show you another example of smarter tooling. I have here this file, and this file is called through all my whole application. My whole application called this file here. You can imagine it as if it were like an event system for my application. Other parts of my application call it passing an object that looks something like this, kind of if it were like a DOM event. It has a type, only instead of being like click, it's events that happen in my application, like for example, user logged. These objects, they can also have any other arbitrary information. And I have this big switch statement here, and depending on the type of this message or event or action, as I call it here, I'm gonna do something different. Now, if you're into React and Redux, and these look a lot like a reducer for you, well, that's exactly what it is. I just explained it with using different words. So I have this user logged here, and I want to do something about it. So, okay. I'm going to do something about it. So if the action contains a type user logged, I know that it comes with some sort of user information, but I don't remember what is what is it. I don't know if it's action.user or if it's action.user token. And what usually would happen is that I would have to go through my application and look where this object was created to see which kind of additional keys and values it uses. But because I'm using TypeScript here, it provides auto-completion on my own application. So it knows, this is not guesswork, it knows that the action whose type is user logged contains name, profile picture, token, and a type. So it helps a lot in this sense. Cool. So smarter tooling. That's another big benefit of using these tools. And the last one that I'm going to show you is kind of my favorite. It's to code in the type level. The type system in TypeScript and FlowType, they're so expressive that they were even proven to be Turing complete, meaning that you can code a complete application just in the type level. I'm not going to do that. I'm going to show you a tiny example just to illustrate how powerful this can be. So I have this piece of business logic here. I have this button function here that will return me a button of some sort. You can imagine that it's like a React component or just a function that returns me a template. It doesn't matter what it does. What matters is that it accepts an object containing a color, an icon, and a text properties. And all of those are optional. Color, if I do not provide a color, it will use a default color. If I do not provide an icon, it will use just the text. If I do not provide the text, it will just use the icon. Now, of course, there's a catch. I cannot not provide both an icon and a text. At least an icon or the text need to be there. So I have to make this small business logic evaluation in my code. So if I'm going to use JavaScript, it's easy to do. I can just make an if statement. If there is no icon and no text, then, well, then what? Do I console log and hope that the other developer is going to see it? The other developer being someone else in your team, or you yourself 3 weeks from now? Do I throw an error and hope that someone catches it and it doesn't explode in the face of your user? Well, if you're using TypeScript, you can again encode that in the type level. I already created this button type here, and this is already done. So if I remove icon, it's okay. If I remove color, oh, missing a comma here. If I remove the color, it's okay. But if I remove both text and icon, it immediately complains. And now it's impossible to publish this file because it has an error. The error shows here on Visual Studio Code. You can configure on any other IDE that you're using. It shows in the terminal where I'm running TypeScript compiler. So it makes it quite impossible to ship this. So granted, this was a tiny example, but you can create incredible sorts of validations here. So just to show you how I did it, I'm not going to get into details here, but I just created like 2 object types, and I can say that you can use one or another, and one has a mandatory text, the other has mandatory icon. So that's how it's done. Now, if you're into React and you're wondering, would that work in React? Well, yes, that exactly same thing. Now this is a React file, and if I do not provide the color, that's okay. If I do not provide the icon or the text, that's okay. But if I do not provide the icon and don't provide the text, now it complains and it says that I have to provide at least one of those. Cool. So before I dive into what it takes to learn these tools, yes, this is TypeScript and FlowType. They are amazing. They have lots of benefits, and they have gained a lot of popularity in the past few years, and so much so that it's starting to become very divisive. There are lots of users that says that yes, this is the salvation. You cannot possibly create anything serious without using them, which is obviously an exaggeration. And there's also people from the other side of the extremes saying that, well, you don't have to use this. If you are a knowledgeable developer, you should be able to handle all the errors yourself without using these tools. And to that, I just say that, well, if you're a safe driver, then you don't use seatbelts. Well, the fact is, these are extremes, and the truth is somewhere in the middle. But these are just tools, and they're as valid as tools such as automated testing, version control, code review, CI/CD, and many other tools and practices of modern software engineering. So investigate for yourself. They do have value depending on your project, depending on your team size, depending on a lot of factors. The effort to adopt will be different, so it's up to you to decide whether you should use it or not. So talking about deciding whether you should use or not, what's the amount of effort that is needed to learn these tools? Well, I did a very informal research, not scientific at all. I just asked a bunch of people, some famous library authors, some very junior developers that use TypeScript. I asked them how long it took them to learn the basics and how long it took them to feel comfortable and productive with the language. And these are granted very open questions, because what's basics for one is not for the other, but I really wanted to leave it open because I want to gather the feeling that these people had. So how long did it take you to learn the basics? Well, anything from a day to a couple of weeks. And how long did it take you to feel productive in TypeScript? Anything from a month to 3 months. So of course your mileage will vary, but if you're interested in learning, that's the amount of effort that you might be looking into. And what are some good resources to learning? Well, there's the TypeScript Handbook. It's the official documentation on TypeScriptLang.org. It's an amazing guide, free to read. I would recommend everybody to explore. There's also a book being written by Dr. Axel. I won't pronounce his last name because I don't know how to do so. He's the author of some very other popular JavaScript books, and he's writing this book. And the first half is free to read online, so I highly encourage you to check that. I also really liked Programming TypeScript by Boris Cherny, so feel free to check it out. That's a paid book, but it's really well done. Okay, so because this is a conference about the future of the platform, to finish and to wrap, I'd like to talk a little bit about my personal wish list for things that I want to happen in the future with tools like these. For one, I would love to see more JavaScript libraries supporting TypeScript. Definitely Typed is doing a killer job in that front already. Definitely Type is a GitHub repository where anyone can contribute only the types to popular JavaScript libraries. Give you an example. React itself is not written in TypeScript and it doesn't contain TypeScript types or type annotations, but there are types for TypeScript for React indefinitely typed. So you install both, and for Visual Studio Code or for any IDE that you had configured, it works as if it were written in TypeScript. All the type annotations just work. So great job, check it out. And I would love to see also a little bit more experimentation in the area. We are approaching this moment where these tools become more commonplace. And when adding a gradual type system, which means adding a type system to a language, a static type system to a language that doesn't have one, there's many approaches that you can take. And with these approaches, there are lots of different trade-offs. So there you can have more flexibility or you can have more type safety. And I would love to see more experimentation in this area to see what's possible. One project that is really cool that is being created by in the open source right now, it's called Hegel. It's being done by one developer, and it aims to be much more stricter than TypeScript and FlowType, but at the cost of catching much more bugs. It's going to be very interesting to see how these tools evolve and hopefully how they cross-pollinate back into popular libraries such as TypeScript.